I said there's two different ways to multiply vectors. The one we went through called the dot product. And by the way, the result of a dot product is a scalar, meaning just a number. So that's a dot product. We went through that. The other thing that's a multiplication type thing is the cross product. Here's its notation, A cross B. It means this, where these are the components of the two vectors. This is the hard way to think about it. The way we think about it usually is taking this determinant, now that we've had matrices. So if you look at it, the determinant of this, I'll have an I times A2, B3 minus B2, A3, right? That's that. The J would be J times, well, minus J, A1, B3. Anyway, if you take this determinant, you're doing this arithmetic, and that's what the cross product means. So for example, find the cross product of A cross B, where A is given to this, and they're both given as linear combinations of the standard vectors. So what does it mean? We'll do this thing. So set up this determinant, the ijk across the top, A cross B, so A goes next, and it's 2 minus 1, 2. Then B goes on the bottom, minus 1 plus B minus 1. Now we take that determinant. We have I times 1 minus 6. The minus, because it's here J, minus 2 plus 2, plus K times minus 2 plus 2. Oh, J, that was J. Excuse me. K would be 6 minus 1. Cancel, you do the arithmetic, there's the resulting vector. This is the cross product A cross B, and these are the A and B. Some properties. A cross B equals 0 if either A or B is 0. A cross B is 0 if A and B are parallel. A cross B is not the same as B cross A. In fact, it's the negative of it. This is called its anti-commutative. It's not commutative, it's anti-commutative. So order matters. Dot product, it was commutative. Order did not matter. Cross product, it matters. Cross product is associative with addition. Scalar multiple, if I multiply either A or B times a scalar, I can bring it out of the cross product. The resulting cross product will be the same scalar multiple of the unmultiplied cross product. Any vector crossed with itself is 0. A dotted with the cross product is 0, and B dotted with the cross product is 0. A and B are what gets dotted. You put these two guys together, and it means the cross product is perpendicular to both of the vectors that were crossed. As long as those vectors aren't parallel, then you'll get a 0. There's this property where the magnitude of the cross product is the product of the magnitudes times the sine of the angle between those two vectors. Theta again means the angle between the two vectors. Simple example, find a vector that's perpendicular to two given vectors. Well, just take their cross product. And then any scalar multiple of that vector is also perpendicular to it. Because changing the scale of it doesn't change the direction. So we take the cross product, there's the arithmetic, there's the result of the cross product. I I can multiply through by -1 and get rid of the minus signs. It's still perpendicular to these two vectors. Any scalar multiple of this vector is a valid answer. The right-hand rule. You have to use your right hand, not your left hand. A cross B depends on which direction it goes in. If A is where your fingers initially start pointing, and then B is the curve them in the direction of B towards B, the thumb points in the cross product direction, positive cross product direction. So like here, if I cross A cross B, I get this direction for the cross product. This is A cross B up here. If I did B cross A, flip that whole thing upside down. B cross A would be like this, and the cross product would be the negative of this guy down here. You can go through this part yourself for the standard vectors. Any standard basis vector crossed with itself is 0, right? Because any vector crossed with itself is 0. Any standard vector crossed with one of the other two, you'll get the third plus or minus a sign. And there's a demonic, not a demonic, maybe it is a demonic device, but a mnemonic device. This little circle here, IJK going around clockwise. If I do I cross J, I'll get a positive K. J cross K, I'll get a positive I. K cross I, I'll get a positive J. If I go the opposite, so I cross K, I'm going counter, I'll get a minus. J cross I, going opposite direction, I'll get a minus K. And sometimes it's easier to use this than to go through the whole determinant process to calculate a cross product, especially if one of the two vectors is just a single component in a standard basis direction. Like this simple case, I cross minus 3K, pull out the minus 3, that's the scalar, and then it's I cross K. I cross K is minus J. I get a signs cancel, I get 3J, or I can write it this way. I cross this vector in all 3 dimensions. I get a 2 times I cross I plus 3 times I cross J plus 4 times I cross K. I cross I is 0. I cross J is K. I cross K minus J. I get a 0 plus 3K minus 4J, or this is it in vector notation. That's the cross product. And by the way, you can use cross product to find the areas of parallelograms and triangles. Here's sort of a geometric derivation of it. If I describe 2 adjacent sides using vectors, say A here and B there, they're adjacent sides of a parallelogram. Well, the formula for the area of a parallelogram is the base times the height. Base here would be the magnitude of A. The height would be the magnitude of B times the sine of the angle between. So I have magnitude of A times the magnitude of B times the sine of the angle between them. And if you recall, this was just the magnitude of the cross product. So to find the area of this parallelogram, cross A and B, and then find that magnitude. And for a triangle, it was just half the parallelogram, so it's that. So here's an example. Say they give you find the area of the triangle with these vertices. 0, 0, 0. These are points, are position vectors. Well, I can form, what I need are the two vectors, so I can use one of these 3 points as sort of the reference point where I'll sort of bring their tails together. Origin is really easy, so I just subtract off 0, 0, 0. So the two vectors are going to be 0, 1, 2 and 2, 2, 0. Cross them. 0, 1, 2, 2, 2, 0. I get this answer. 4, 4 minus 2. The area of the triangle is 1/2 the norm, or the magnitude of that cross product, which will be 4 squared plus 4 squared plus 2 squared. The answer is 3. So that's cross product. Next, we'll do lines and planes.